we will be discussing about measurement today. Now, whenever we hear this word measurement, generally the thought of measuring a cloth, measuring a distance, measuring height, this type of things, or weighing something, these things come into our mind. Now, when I'm talking about measurement in psychology or in the research methodology, let's first see from where this measurement come and what function does it serve over here. Measurement is actually the root of both biological and the behavioral sciences. In bioscience, the measurement obviously has a very long history, but for the psychological and the educational measurements, it only dates back to 1850. Why? Because prior to 1850, psychology was not an independent branch of science. It was a branch of philosophy. We all know it was seen as a branch of philosophy only. Then after the independence of psychology, after it was recognized as an individual branch, as an independent subject, then the concept of measurement in relation to psychology came into existence. Measurement refers to the process of assigning numerals to the events, objects, etc. according to certain rules. A more elaborate definition that we generally consider is given by Nanali in 1970. He said that measurement consists of rules for assigning numbers to objects in such a way as to represent quantities of attributes. Why I am saying quantities of attributes? Because we know in psychology we deal with attributes. In the process of measurement, numbers are assigned according to certain rules. The investigator assigns the numbers not of his own choice, but according to the specialized rules. That means I won't assign number to an event or an attribute according to my wish or my whim. I will be applying the number in line with the rule that has been devised for assigning the numerals. Measurement is always concerned with certain attributes or features of the objects which are measured and not the object itself. That means the whole object. I am not taking the whole object as the measurement, but we are taking the various attributes of that object for measurement. In the process of measurement, numerals are used to represent the quantities of the attribute. In other words, measurement involves the process of quantification. And this quantification indicates that how much or to what extent that particular attribute is present in a particular object. Now when we are coming to the types, it is generally the levels of measurement. We don't take it as the types, but are the various levels of the measurement. There are actually 4 general levels of measurement: nominal, ordinal, interval and ratio. These 4 levels of measurement, they lead to 4 types of scaling, 4 kinds of scales that are used to measure in psychology. Rules used to assign numbers to the objects define the kind of scale and the level of measurement. That means the rules for assigning numbers are different in the different levels of measurement. These scales are distinguished in terms of several criteria. The higher level scales require more restrictive rules. There are also differences in how much can be done in the way of mathematical and statistical operations with numbers applied at different levels of measurement. That means various kinds of mathematical or the statistical applications that are applied, that are admissible in the various levels, that are also different according to that rules of that level of measurement. Now we will be starting about the first level, the nominal measurement or the nominal scale. This is generally the lowest level of measurement that is used to name, identify, classify or categorize the units. They are assigned to objects which are numerical without having any number meaning. They cannot be added or ordered. They are labels. I'm calling labels. Why? Labeling. It is like singling out something. So these are used as labels, much like that the letters are used to label sets. For example, when right now as the students are divided into two batches, batch A and batch B, or batch 1 and batch 2. Here batch 1, this number of 1 and this number of 2 generally do not have any other number meaning other than just recognizing the two groups as separate. That means in the nominal measurement, it is just used for naming or grouping or classifying the items, classifying the objects into groups. The requirement of the nominal measurements are simple. All the members of a set are assigned the same numeral. Nominal, that means students under batch 1, they are all batch 1. They all have the tag of 1. And the students under batch 2, they will all have the tag of number 2. Nominal measurements are quantified only when a dichotomy is involved. Like a sample of person can be studied as Christian, Parsi, Hindu, and the same sample can again be classified on the basis of their rural urban inhabitants. Or that same group can be again classified into ethical groups. Thus, in nominal measurement, the members of any two groups are never equivalent, but all the members of any one group are always equivalent. And this equivalence is reflexive, transitive, and symmetrical. In case of nominal measurement, admissible statistical operations are counting or frequency percentage, proportion mode, and coefficient of contingency. Since the nominal scale represents only the first characteristic of the number, that is for identification, and does not take into consideration its other properties, namely rank order, equality of intervals, additivity, so no arithmetic operations can be applicable in this level of measurement. In this scale, addition, subtraction, multiplication and divisions are not possible because they are only the identifying numerals. So they do not have any number meaning, and so they cannot be legitimately added, subtracted, multiplied or divided. It is the most elementary form of scale, and according to some experts, obviously, this is not a measurement at all. Now we are moving on to the second level, that is the ordinal scale. This ordinal scale, here the number denotes rank order. As the name implies, ordinal. It is the ordinal number, the order number. Here the numbers are arranged from the highest to lowest or from lowest to highest. That means here the numbers are used to rank order or to present the items according to their ranks. Ordinal measurement requires that the objects of a set be rank ordered on an operationally defined characteristic or property. That means when I am saying it is rank ordered, this means that if A is greater than B and B is greater than C, then obviously A will be greater than C. Other symbols or words can be substituted for greater than or lesser than. That is, we can use symbols for saying this greater than or lesser than other than in words. Ordinal measurements reflect which person or object is larger or smaller, heavier or lighter than the other. So, an example of ordinal measurement can be the socio-economic status of the society, where the members of the upper class are always higher in social prestige or in their economic affluence in comparison to all the members of the middle and the lower classes. Most measurement in behavioral research depends on its postulates. So, as I said, suppose A, B and C, there are three objects, and if A is greater than B and B is greater than C, then obviously you will say A is also greater than C. Then the main condition for the ordinal measurement is satisfied. However, the relation may seem to satisfy this postulate but may not actually do so. Why I am saying this? Because it might be that A dominates B and B dominates C. Then it is not always true that A will also dominate C. This is especially so with regarding the ranking individuals of the behavioral traits, as the psychologist is dealing with the human subjects and we are generally dealing with the human behaviors, traits and attributes. It might be that some postulates do not work in the same manner that they work in the mathematical situations. The procedure can be generalized in three ways. That is, any number of objects of any kind can be measured ordinally simply by extension. How? Like I am ranking them as A, B, C, D, E, F, G, H. That is, if I am ranking them according to their grades also, it is like first, second, third, fourth, fifth, sixth. Like this way. I am just doing this by extending the values. Then again, the second extension consists of using the combined properties or the combined criteria. Instead of using only one property, one can take two properties for scaling. For example, instead of only the academic achievement by grade point average, we can also take the combined criteria of grade point average and the test scores. Next, there is a third extension that is accomplished by using the criteria other than greater than. The numerals assigned to the rank orders are called rank values. Ordinal numbers indicate rank order and nothing more. That means here when I am doing ranking, this number only denotes your position and nothing more than that. When I am saying somebody is first in class, the rank order is 1, and somebody is second, the rank order is 2. That doesn't mean the person has received the score of 1 or score of 2. It only denotes your position and not any other meaning of number is found from here. These numbers do not indicate absolute quantities, nor do they indicate that the intervals between the numbers are equal. Why? Because the rank order scales do not have an absolute 0 point, obviously. So obviously their values are not absolute, and their differences of scores, differences of ranks are also does not the difference between the ranks also does not depict equal distances between the ranks. The permissible statistical operations in this measurement is median, percentiles, rank correlation coefficient, plus all those which are permissible for nominal measurement. Just think of one thing, whenever we are progressing to the higher level of measurement, all the characteristics of the lower level scales are getting added in a cumulative way to the higher levels. That means the higher level scales obviously have the characteristics of the lower level scale, plus they are having their own characteristic. That means the nominal scale characteristics of naming or categorizing, that is also present in ordinal scale. And in addition to that, in ordinal scale we are also can use the numbers that are assigned. They are not only naming you, they are not only categorizing you, but at the same time they are giving you your rank position, your ordinal position in that group. As we will progress to the next level, we will see that level will have the characteristics of the lower two levels, that is nominal and ordinal, plus will have something special that is unique to that scale. Okay. Now next we are moving on to the interval scale. This is also called an equal interval scale. As I have said, it will possess all the characteristics of the nominal and ordinal scales. Other than that, it has a special characteristics, that is, there are numerical equal distances on the interval scale. That is, the property being measured on the interval scale, their differences of the scaling scores, of the scaling, the units, they are equally spaced. Suppose that 4 objects are measured: 8, 6, 5 and 3. Here one might legitimately say that the difference between the first and the third object, that is, if we say 8, 6, 5 and 3, then first object will have the score value of that object will be 8 and third is 5. And again for the second is 6 and the fourth is 3. Then we can easily say that the difference between the first and the third, that is 8 minus 5 is 3, and which is equal with the difference between the second and the fourth, that is 6 and 3. When 3 is subtracted from 6, we are getting again 3. Interval scales are called equal unit scales. The important property over and above those in the lower types of scale is that numerically equal distances stands for empirically equal distance in the same aspect of the object. It is the third level of measurement, that is, interval is the third level of measurement where the unit measurement is constant and equal. On an interval scale, the intervals or distances can be added in the absolute sense. The process of additivity of intervals on an interval measurement has only a limited value, because in such a measurement the point is not true but rather arbitrary. That means the 0 point is an arbitrary 0 point. It is not the exact 0 point. That means what is the exact 0 point? That is exact 0 point is that the mathematical 0 which marks the absence of the property. Now in the interval scale and basically in the psychological setup, we can't have that absolute 0 point. Like a person can be, if we think of the attribute of honesty, then there can be a person's honesty can be expressed in terms of degree, but there we can't say an attribute is totally absent in a person. It can't be an all or none phenomenon. It can't be that a person is either honest or totally dishonest. Dishonest is like, we can say it in degree. Okay, he is more honest than that person, but it doesn't mean that the person will have a 0 honesty. Okay, this is basically the point of the interval scale. And the common statistics that can be used in this measurement is mean, SD, Pearson R, and other similar statistics. As I said, it does not have an absolute 0 point, so other higher level of statistics are not permissible over here. Now we are moving on to the last level of measurement, that is the ratio scale. It is the highest level of measurement and has all the properties of nominal, ordinal, interval scales, plus what was lacking in all the 3 scales? An absolute 0 point. That is the point from where the measurement actually starts. That is the point of absence of measurement. In this ratio scale, this thing is present. That is, the absolute 0 point is present in ratio scale. The salient feature of the ratio scale is that the ratio of any two number is independent of the unit of measurement, and therefore it can be equated. For example, if we see the ratio as 16:28, how we can express it? Again, when we write 16:28, the common factor that we find out will be, that means 4:7. This will be the ratio. The 0 point stands for neither more or less than none of the property represented by the scale. All the postulates of measurement, we will be talking about the postulates in some time. All the postulates of the measurements are applicable in this scale, and obviously is an ideal scale for all scientists. Since there is an absolute 0, all the arithmetic operations are possible, including multiplications and divisions. Numbers of the scale on this scale, they indicate the actual amount of properties being measured. Why actual? Because it starts with an actual 0 point. So it does not have an arbitrary standpoint. It is standing on a fixed 0 point, so it can be easily compared and obviously have a stable point of start. The common examples of ratio scales are the obvious, it's the length, breadth, height, weight, this type of thing. Now, since the starting point is fixed and stable, the numbers on the scale represent the absolute magnitudes of the property being measured. Now, this ratio scale is also called a ratio scale because the numbers assigned to the points on the scale signify also the ratio of the measured values of the objects to whom the numbers are assigned. That is, when I am saying 16 is to 28, see, it is the ratio. That means the ratio will be 4 is to 7, and this is the relationship between those two attributes which are reflected or presented in this ratio. It is obvious that ratio scales are common among physical sciences, obviously, but in social sciences, this actually doesn't work so much because of that true 0 point, as I said, because in psychological or in behavioral sciences, we generally do not say things as an absence of a property. We generally do not see one person, there can be a variable degree of intelligence, but we can't say zero intelligence. No, there can be a varying degree of intelligence, levels of intelligence, but there can't be a zero intelligence. Okay, so this was the concept of the measurements, and when we are talking about measurement, we should study about the simple postulates of the measurements. Now, what are these postulates? As I was saying, these are some assumptions which stipulates the relationship between the groups, and this is what the basis of all measurements that are done. Now, there are actually 9 such measurements, and these are pretty easy. The first postulate is like either A is equal to B or A is not equal to B. That means if there are two objects A and B, there can only be two options. Either A and B are equal or A and B are not equal. No other possibility are there of any other relationship possibilities are there. The second is if A is if A is equal to B, then B is equal to A. So if I have two groups and if I have two properties and I am saying that this A is equal to B, then obviously B is equal to A. Then the third postulate is if A is equal to B and B is equal to C, then you can easily say that A is equal to C, because it is already postulated A is equal to B. So A and B are equal, B and C are equal. So that means A and C are equal. Then the fourth postulate is if A is greater than B, then obviously B is not greater than A. That means if in a relationship pattern, in the relationship of two properties, one property is greater than the other property, the one which is smaller, it can never be greater than the bigger property. Okay. Then the fifth postulate is if A is equal to B and if A is greater than B and B is greater than C, then obviously A will be greater than C, because B is already greater than C. So C is the smallest over here because A is already greater than B. So obviously A will be greater than C. In the sixth postulate, it is if A is equal to P, P stands for probability, and B is greater than 0, then the postulate is A plus B will be greater than P. Okay, like we do it in simplification, we write over here A is equal to P, then B is greater than 0, then A plus B will be greater than P. Next is if A plus B, that is A plus B equals to B plus A. If we add A plus B, the value will be same if we add B plus A. Then the eighth postulate, if A is equal to P and B is equal to Q, then A plus B is equal to P plus Q. And the ninth postulate is A plus B in bracket plus C will be same or will be equal if we express it as A plus B plus C in bracket. That is, there are three things A, B and C, and if we represent the equation as A plus B in bracket plus C, this will be same or equal if we add it as A plus B plus C in brackets. So these are the 9 postulates that is followed in the measurement techniques in all mathematical applications, and these are the basis of measurements. So this is what we all should study, know about the different levels of measurements, and with this we have completed this topic of measurement. If it's clear to you or you have any doubts, then obviously you can reach to me in my doubt clearing class, or you can comment in the Google Classroom in our classmates or in the comment box below. Thank you, class.